In this video, I'm going to show you how to solve a nonlinear system of equations given a linear equation and a quadratic equation. So a linear equation is a line looking like something like that, maybe going the opposite direction, and quadratics are U-shaped graphs either right side up or upside down. So there's a few scenarios where like these could cross. Maybe I have a quadratic as being intersected by a line and it crosses in these two spots. Or maybe I have upside down quadratic and the line is just crossing it once. Maybe I have a line that is perfectly horizontal and it's never going to cross. So there's a lot of scenarios that can happen with systems, but what we're looking for is where do they intersect? What ordered pairs or points do they have in common? So to do this, I'm going to use substitution. And when you use substitution, you want to find one of the y values by itself or x values by itself. You need a variable isolated. So if it's not given to you, you may have to do that yourself. However, I have y isolated. Y is equal to x minus 2. So I'm going to take x minus 2 and I'm going to plug it in for y. So I have x minus 2 minus 23 is equal to x squared plus 11x. Now I used parentheses here, but I don't really need to because there's nothing in front of the parentheses to distribute in. So I can go ahead and drop those parentheses and combine like terms. Negative 2 minus 23 is going to give me a negative 25. And then my right-hand side has no like terms. When I look at this, I see a quadratic equation. I can't do anything here but solve it by factoring or quadratic formula. So I need to get it equal to 0 to be able to do that. And so I'm moving those two terms over to make it equal to 0. I'm using opposite operations. I'm combining like terms. 11x take away x is 10x. Drop down my 25. And now I'm going to factor if I can. If you can't, you might have to use quadratic formula, but luckily this one is factorable. And so x plus 5 times x plus 5 is this quadratic equation factored. And I do have a video on how to factor when a is 1 if you're interested in watching or need a refresher. So here the answer to these to this quadratic or to figuring out where these factors are 0 is to set them equal to 0 and solve for x. So if I do x plus 5 equals 0 and take away 5 from each side, I would end up with x is equal to negative 5. Now, if I set the other factor equal to 0, it's going to also be negative 5, so I don't have to do that part. But I do need y because I need the ordered pair where they intersect. So I'm going to take my x value and I'm going to plug it back in for x. It does not matter if you use the top or bottom equation. However, the bottom equation looks more simple. So I'm going to do y is equal to negative 5 take away 2. I put negative 5 in for x. I end up with negative 7. And so my ordered pair is negative 5, negative 7. A way to check this without a calculator would be to plug it back into the other equation and make sure it works. But the easiest way is if you have a graphing calculator. I have Desmos on hand, so I'm going to show you that that's the answer in Desmos. I already have it typed in. Now, a lot of times in Desmos, it will let you just click on the dot, and sometimes it can be finicky. And for me, right now, it is being finicky, of course, because I'm trying to show you, but that's where they're crossing. The other way you can do this, though, is after you type it in and you hit the, I know why it's doing it. It does not like that this y is not by itself. So I'm going to move the 23 over by making it positive. And I bet now it lets me click that dot. No, it's still being finicky. But I can hit the settings wheel button in the table now. And I can type in negative 5. And then I can go here and hit settings wheel table. And I can type in negative 5. And I can see that they're both negative 5. Negative 7 is where they intersect. So that's how you can check it. Hope this